There are holes on our planet that defy all logic. Some are so enormous they can only be seen from space. Others are hidden beneath a kilometer of rock and ocean water, and we only know of their existence because 66 million years ago they destroyed 75% of life on Earth. Still others look like portals to another world, perfectly round, bottomless, so blue it feels like looking into the pupil of the planet itself. Each of these holes is a mystery that scientists have spent decades trying to solve, and each one tells a story that takes your breath away. 4 holes, 4 stories. Let's go. The first hole is in the middle of the Sahara, the largest and most lifeless desert on Earth. If you fly over Mauritania and look down, amid the endless red sand, you suddenly see something impossible. A gigantic circle, almost 50 kilometers in diameter, composed of perfectly concentric rings, like a target painted on the planet's surface. Dark rings alternate with light ones, and the entire structure is so perfect, so geometric, that your first thought is that something intelligent created it, not nature. Nature doesn't draw perfect circles 50 kilometers in diameter, and yet, there it is, the Eye of the Sahara, or the Richat structure, one of the most enigmatic geological formations on Earth. The Eye of the Sahara was first noticed in the 1960s, when the first Gemini astronauts looked down at Earth from space and saw a strange circle in the desert. Before then, almost no one knew about it. The structure is invisible from the ground because it's so large. You could stand on one of its rings and not realize you were inside a giant circle. Only from an altitude of several hundred kilometers does the pattern emerge, and it's striking. Astronauts used the Eye of the Sahara as a landmark during flights over Africa. In the monotony of the desert, it was the only noticeable feature. The first theory about its origin was obvious: a meteorite crater. The perfectly round shape, concentric rings, and location in the middle of a flat desert all pointed to the traces of a cosmic impact. But when geologists reached the site and began their investigation, this theory fell apart. In meteorite craters, the rock is melted and deformed by the shock wave, and it contains specific minerals, coesite and stishovite, that form only under extreme pressures. None of this was found in Richat. The rock was not melted. There were no impact minerals. It was not a crater. So what is it? The currently accepted hypothesis is that the Richat structure is the result of a geological uplift, or dome, that began forming about 100 million years ago. Deep underground, a magmatic flow pressed down on the surface, lifting layers of sedimentary rock. These layers, of varying ages and hardness, were lifted and exposed, and then, over millions of years, erosion washed away the softer rocks, leaving the harder ones as protruding rings. Essentially, the Eye of the Sahara is a cross-section of Earth's geological history, turned inside out and polished by wind and water to form a giant target. Each ring represents a layer of rock of a specific age, from Proterozoic rocks, over 500 million years old, to Ordovician rocks, only about 450 million years old. But this theory doesn't satisfy everyone. Some geologists point out that dome-like uplift doesn't typically create such perfectly round shapes. Natural domes are typically oval or irregular. They're deformed by tectonic stress, rock heterogeneity, and asymmetrical magma flow. Richat, on the other hand, is a near-perfect circle. Furthermore, kimberlite rocks, the very same rocks in which diamonds form, have been discovered in the structure's center. Kimberlites are associated with powerful volcanic explosions that lift material from deep within the mantle. Could Richat be the remnant of a colossal volcanic explosion that occurred tens of millions of years ago? An explosion that didn't leave a traditional crater, but deformed rocks over an area of thousands of square kilometers. There's also a more exotic theory that regularly pops up online. The Eye of the Sahara is the ruins of Atlantis. Its dimensions match Plato's description of a round city with concentric rings of canals. Its location is west of the Mediterranean, in or near the Atlantic. The Sahara was once green, and rivers flowed through Richat. Of course, no serious scholar supports this theory. There's not the slightest archaeological evidence of human presence in Richat, but it persists, fueled by visual similarities and the human need to believe in miracles. The Eye of the Sahara still gazes into the sky, and still holds its secret. What makes Risha particularly mysterious is its context. The Sahara wasn't always a desert. Just 5,000 to 6,000 years ago, during the so-called Green Sahara, rivers flowed, lakes splashed, forests grew, and people lived here. Rock paintings in the Tassili Najer Mountains, several hundred kilometers from Risha, depict giraffes, elephants, hippopotamuses, and people sailing in boats. If the Eye of the Sahara existed back then, and it certainly did, it's much older, then ancient people saw it. They lived near it, perhaps even inside it. Its rings could have served as natural walls, and the lowlands between them, riverbeds. Did they know they were living inside a giant circle? Probably not. That would require a view from above, which they didn't have. But they may have known the place was special. They may have considered it sacred, and perhaps the memory of this sacred place survived into antiquity, transformed into the myth of Atlantis. This is speculation, not science, but beautiful speculation. The second hole is the oldest and largest impact crater on Earth. It's located in South Africa, about 120 kilometers southwest of Johannesburg, and it's called Vredefort. If you go there, you'll see rolling hills, green fields, small farming villages, a typical South African landscape, unremarkable in every way. You won't see the crater, because the crater is all that surrounds you. Vredefort is about 300 kilometers in diameter. You can't see it from the ground, for the same reason an ant can't see the soccer ball it's standing on. You're inside. 2,023,000,000 years ago, give or take 4 million years, an asteroid between 10 and 15 kilometers in diameter slammed into this spot. Imagine, a rock the size of a small city flying at about 20 kilometers per second. The impact energy was on the order of 10 to the 25th power joules. That's billions of times more powerful than humanity's entire nuclear arsenal combined. At the moment of impact, the temperature at the point of impact rose to tens of thousands of degrees. The rock vaporized. Not melted, but vaporized, turning into superheated gas, which the shock wave propelled into the atmosphere to a height of hundreds of kilometers. The Earth's crust over an area of thousands of square kilometers was deformed, crumpled, and overturned. Rocks buried at a depth of 25 kilometers were pushed to the surface. The shock wave circled the planet several times. But here's what makes Vredefort truly unique. It's not just old. It's so old that it raises a fundamental question. How did it survive at all? 2 billion years is almost half the age of the Earth. During that time, tectonic plates have shifted thousands of kilometers, mountains have risen and been pulverized, oceans have appeared and disappeared. Most craters that old have long been destroyed by erosion and tectonics. Vredefort survived thanks to the unique geology of the South African Craton, an ancient, stable region of the Earth's crust that has been largely unaffected by tectonic deformation. It's as if an impact had left an imprint on a slab of concrete rather than Play-Doh, and the imprint was preserved. Vredefort is an invaluable object for science. It allows us to study the consequences of super-powerful impact events under conditions that cannot be reproduced in the laboratory. Geologists have discovered so-called shutter cones in the crater's rocks, cone-shaped structures that form only with shock waves of a certain intensity. They found quartz grains with characteristic planar deformation elements, microscopic cracks aligned parallel to crystallographic planes, which are irrefutable evidence of an impact. They also found molten rock, called impactite, preserving gas bubbles that were sealed 2 billion years ago. Today, Vredefort is a UNESCO World Heritage Site, but most South Africans have no idea they live inside the largest crater on Earth. The town of Vredefort, with a population of just a few thousand, stands almost at the center of the impact. Farmers plow fields on rocks that were molten 2 billion years ago. Children play on hills that are actually protrusions of the peak ring, a ridge raised by the shock wave from deep within the Earth's crust. The Vaal River, which flows through the crater, has carved a picturesque gorge in the ancient rock, popular with whitewater rafting enthusiasts. They descend the rapids, unaware that the rocks around them are a frozen memory of an event that nearly sterilized an entire hemisphere. There is something simultaneously eerie and hopeful about this. Life not only survived the impact, it inhabited it, transforming the planet's scar into farmland, a river, and a playground. But the most intriguing question surrounding Vredefort isn't geological, but biological. 2 billion years ago, life on Earth consisted of single-celled microorganisms. Some scientists suggest that an impact of such magnitude could have radically altered the evolutionary trajectory of life, for example, by destroying existing ecosystems and creating conditions for the emergence of new, more complex forms. Others believe the impact could, conversely, have sterilized part of the planet and set evolution back. The truth is likely somewhere in between, but it's impossible to determine with certainty. 2 billion years is too long, and traces of the biological consequences have long since been erased. The third hole is the most famous and deadliest of them all. It's located on the coast of Mexico's Yucatan Peninsula, and it killed the dinosaurs. The Chicxulub crater, approximately 180 kilometers in diameter, buried under a kilometer of sediment and partially obscured by the waters of the Gulf of Mexico, is the mark of an impact that 66 million years ago wiped out 3/4 of all species on Earth and closed a 150 million year chapter, the age of dinosaurs. The story of Chicxulub's discovery is a detective story in itself. In 1980, Nobel laureate Luis Alvarez and his son Walter published a groundbreaking paper proposing that the mass extinction at the Cretaceous-Paleogene boundary was caused by an asteroid impact. The evidence was a thin layer of clay enriched with iridium, which is found in geological sections around the world at the boundary between the two eras. Iridium is a rare element on Earth, but common in asteroids. If an asteroid had struck Earth, it would have dispersed into the atmosphere, and the iridium dust would have settled in an even layer across the planet. The hypothesis was elegant, but it lacked one thing: a crater. Where were the impact marks? Without a crater, the theory was simply a beautiful idea. The crater was discovered 10 years later, and it wasn't an archaeologist or a geologist who discovered it, but an oil man. Glenn Penfield, a geophysicist for the Mexican oil company Pemex, had discovered a strange, ring-shaped anomaly on gravity maps of the Yucatan Peninsula back in 1978, a semicircle, partly hidden beneath the sea and partly beneath the jungle. He reported the discovery, but company management wasn't interested. There was no oil there, and therefore nothing to discuss. Penfield published a brief report, which went unnoticed. Only in the early 1990s, when a journalist linked Penfield's work to Alvarez's hypothesis, did the world finally take notice. Drilling confirmed that a crater of the right size and age lay beneath the Yucatan Peninsula. Chicxulub had been found. What happened 66 million years ago? Reconstructing the event sounds like the script for an apocalyptic movie, except it's real. An asteroid approximately 12 kilometers in diameter entered the atmosphere at an angle of approximately 60 degrees and slammed into the shallow shelf off the coast of Yucatan. At the moment of impact, the explosion had the energy of approximately 100 teratons of TNT, 10 billion times more powerful than the bomb dropped on Hiroshima. The rocks at the impact point were instantly vaporized. The shock wave, a red-hot wall of compressed air, raced across the planet at thousands of kilometers per hour, destroying everything thousands of kilometers from the epicenter. A mega tsunami, 1.5 kilometers high, struck the coasts of both Americas. Superheated rock fragments, thrown into space, rained back down to Earth, setting forests across the planet ablaze. The sky became covered in dust and soot, temperatures dropped, photosynthesis ceased, and food chains collapsed. This went on for months and years. The dinosaurs, who had ruled the planet for 150 million years, died out. Along with them, the ammonites, mosasaurs, pterosaurs, and most marine reptiles perished. Small mammals, birds, crocodiles, and turtles survived, those who could hide underground, feed on carrion, and endure the cold. But here's what's truly astonishing. In 2016, an international expedition drilled a hole more than 1,300 meters deep directly into the peak ring of the Chicxulub crater, a ring-shaped structure raised by the shock wave in the crater's center. Cores, cylindrical rock samples extracted from the hole, told the story of the impact down to the minute. At a certain depth, the rock was melted and mixed with basement fragments, granite and gneiss, dredged up from depths of more than 10 kilometers. Above that is a layer of breccia, composed of fragments of all the rocks encountered in the shock wave's path. Even higher is a thin layer with a high concentration of iridium, the very same Alvarez layer. And above that is limestone that bears not a single dinosaur footprint. This is what the end of an era looks like, a layer of iridium several centimeters thick, separating a world where dinosaurs lived and a world where they don't. core studies revealed another surprise. It turned out that the asteroid struck sulfur-rich rocks, gypsum and anhydrite, and the impact ejected colossal volumes of sulfur aerosols into the atmosphere. These aerosols, not dust and soot, were the primary cause of the nuclear winter. They reflected sunlight and caused global cooling that lasted for decades. Had the asteroid struck a few hundred kilometers to the east or west, into the deep ocean where sulfur rocks are absent, the impact would have been significantly less catastrophic. Dinosaurs might have survived. Mammals might never have had a chance. Humanity might never have emerged. The fate of life on Earth was determined by a few hundred kilometers, a microscopic distance on the scale of space. The fourth hole is the most beautiful and perhaps the most photogenic of them all. It's located off the coast of Belize, in the Caribbean Sea, and is called the Great Blue Hole. If you look at it from above, you'll see a perfectly round disk of the deepest blue, surrounded by a ring of turquoise shallows and snow-white coral reefs. The diameter is 318 meters. The depth is 124 meters. It's as if someone took a giant compass and cut a perfect circle in the coral reef, filling it with ink. The Great Blue Hole is a sinkhole formed during the Ice Age, when sea levels were 100 meters lower than today. At that time, the area of what is now Lighthouse Reef, where the hole is located, was dry land covered in limestone cliffs. Rainwater, saturated with carbon dioxide, dissolved the limestone, creating underground caves, the same process that forms stalactite caves around the world. One of these caves collapsed, creating a vertical shaft with sheer walls. When the Ice Age ended and sea levels rose, the shaft was flooded, becoming the blue hole we see today. Jacques-Yves Cousteau included the Great Blue Hole in his list of the top 10 diving spots in the world. In 1971, he brought his famous vessel, the Calypso, here and conducted a series of dives that made the hole world famous. At a depth of about 40 meters, Cousteau discovered what attracts divers from all over the world: giant stalactites, stone icicles hanging from the ceiling of a flooded cave. Some of them reach several meters in length. They formed when the cave was dry, tens of thousands of years ago, and remained intact after the flooding. Swimming among these stalactites is like floating inside a flooded cathedral, stone columns receding into darkness, silence broken only by the sound of one's own breathing and the sensation of time standing still 10,000 years ago. But the Great Blue Hole is more than just a museum. It's a living ecosystem. Its walls, in the upper layers where there's still enough light, are home to coral gardens of incredible beauty. Reef sharks, giant groupers, barracudas, and sea turtles are common here. Schools of tropical fish swirl in the clear water, and visibility sometimes reaches 60 meters. You can see the opposite wall of the hole as if looking through glass. For divers, this place is a pilgrimage. Every year, thousands of scuba enthusiasts from around the world flock here to dive among the stalactites. But diving in the Great Blue Hole is dangerous. The depth, the lack of a bottom for much of the dive, the abrupt transition from clear water to complete darkness, and the narcotic effects of nitrogen at great depths make it one of the riskiest recreational dives in the world. Several divers have died here, becoming disoriented in the darkness or miscalculating their air supply. But the real surprise awaited at the bottom. In 2018, an expedition led by Richard Branson and oceanographer Fabien Cousteau, the grandson of Jacques-Yves, dove to the bottom of the Great Blue Hole in submersibles. At a depth of over 100 meters, they discovered a layer of hydrogen sulfide, a toxic gas that forms an impenetrable barrier separating the upper, oxygen-rich layers of water from the lower, completely oxygen-deprived layers. Below this layer, there was no life, no fish, no corals, no algae, only absolute darkness and dead water. But there were discoveries. On the bottom lay the shells of giant clams, the carapaces of ancient crabs, and, most unexpectedly, stalactites that had fallen from the cave ceiling, lying on the sea floor like the fallen columns of a ruined temple. Some of them were tilted at an angle that was not vertical, which led scientists to believe that an ancient earthquake had tilted the cave before it was flooded. But the most shocking discovery was something else entirely. A 2-liter plastic bottle was discovered at the bottom. In the middle of a flooded 10,000-year-old cave, among stalactites formed over millions of years, at a depth of over 100 meters, plastic trash. Fabien Cousteau said at the time, "We dived into one of the most pristine places on the planet, and the first thing we saw at the bottom was our trash." This phrase traveled the world and became a symbol of how far human pollution had penetrated, even to places where, it would seem, there can be no trace of civilization. 4 holes, 4 stories about the planet we live on. The eye of the Sahara, which gazes into space and refuses to explain its nature. A gigantic circle in the middle of a dead desert, too perfect for nature and too ancient for humans. Vredefort, which preserves the memory of an impact 2 billion years ago, an event of such power that we can't even imagine it, only measure it in numbers with 20 zeros. Chicxulub, which wiped the dinosaurs from the face of the earth and cleared the way for us, and which was discovered by chance by an oil worker whose boss didn't want to waste time on a useless circle on a gravity map. And the Great Blue Hole, which is simultaneously one of the most beautiful places on the planet and a reminder that even to the bottom of the deepest and most distant caves, we have managed to deliver our trash. These 4 holes have one thing in common. They make us feel small. Not in a bad way, but in the sense that small means part of something unimaginably large. We live on a planet that is 4.5 billion years old, on a surface that has been bombarded by asteroids, torn apart by volcanoes, and flooded by oceans. Each of these holes is a scar left by time on the body of the Earth, and each scar is a reminder that our planet is not a backdrop for human life, but a living, breathing, dangerous world that existed long before us and will exist long after. We simply peered into a hole and saw an abyss, and the abyss, as usual, peered back. Because each of these 4 holes is more than just a geological feature. It is a mirror reflecting the scale of our ignorance. We thought we knew our planet, and then we looked down and realized we didn't even know what was beneath our feet, and that's perhaps the most exciting discovery of all.